Hi there, my name is Henning, aka Don Data, and in this video I would like to show you some basic SQL queries. I will be using the White World Importers database from Microsoft. It's a free demo database that you can download as well. I will put the link in the description. And with this one we will be able to do some basic select queries where we define the tables that we want to select from. We will be filtering our result sets with the where clause, and later also go ahead and bring together different tables via join functionality and do some simple calculations. So at the end of this video, you will have seen how to query your data on a very high level, but very fast pace, and I hope you will enjoy it. All right, here I am already in my SQL Server Management Studio. I'm connected to my local host, so the one running on my machine itself, and I have the White World Importers database attached to my local server. And if I open here the tree menu and go into the tables, we see that in this demo database we have a lot of tables. And at first we are interested in the sales orders. So this table, something we can query. And when we query something, we start with a select. Let's make an asterisk here from sales.orders. Typically, we would put our commands in a new line like this, and let's execute this query. And there we already get our results. So this asterisks that I'm selecting here means give me all the columns that are present in this orders table. And this is what we have here. We have an order ID, we have our customer also identified with an ID, an identifier, salesperson, person ID, so which salesperson was responsible for a sale, and so on. An order date is also interesting to see. Okay, so far so good. Now let's say I don't want to get all these rows all the time. I'm only interested in the subset. And then instead of making this asterisks here, I would go ahead and say I'm only interested in the order ID maybe, and comma separated. Let's get the customer ID. We want to know who was responsible for a sale. That's the salesperson person ID, and the order date. If I execute this query, we are down to the 4 columns that I selected here from this table. So far so good. Now we see here they look quite ordered by order date, but this is just by random chance, because probably the data was entered in that order into the database. But I can also specify an order by. An order by is used to sort our results. Let's say I want to order by our customer ID. And when I run this, I will first get all the orders from the customer 1 and so on, 24, 25, 27, if I scroll down. So this is how we order a result set. And we can also order by multiple columns. So when we see here from customer 1, the order date is now in random order because we did not specify a second order. So we can, with a comma separated, say we want to also order by order date. If I run this, we see for the customer 1, the first order that this customer placed was on the 4th of March in 2013, and so on. I could also go ahead and change the order to descending order. Standard would be ascending or ASC. So let's see what this does. So the customer ID is still in ascending order, but then we start with the latest order for this customer, the order date, descending. Cool. This is how we order our results. Now let's see who is behind this salesperson. I will now go ahead and make a second query here and select asterisk from application dot people. This is, I know, where the persons are in. And in this table, as you see, I have marked this part and hit execute, and only this query will be executed. And we have a person ID here and a full name and a lot of other stuff that we are not interested in for now. But this table is something I can use. Now I want to see which salesperson person ID refers to the person ID in this table and gives me the full name. So to do that, I need to join together two tables, and this is what we are going to do now. After the from, we will have an inner join application.people. And now we need to specify how we want to join it. We want to join it on the salesperson person ID from this table, and this one shall be equal to the person ID from the second table, from our people table. So we have a person ID. And now I will remove this again. We can then also get the full name from our people. If I execute this, now we see the salesperson person ID number 7. Her full name is Amy Treffel. Our salesperson person ID 13 is Mr. Hudson Hollenworth. And now that we know the name, we are not interested in the ID anymore. All right. This begs the question, how does our system know which column to take from which table? In this case, it just works because the names of the columns are unique over those two tables. But typically, I would give here an alias. Let's call this one O, and here I will call this one P. The syntax is just I put in blank space and then I give it a name, and it can be longer than one character, but for abbreviation I will do it like this. And now I can always specify with this alias that I want to take the salesperson person ID from the table P, and the person ID shall come from the table O. So that makes it more precise. So the full name comes from table P, and from the table O we have the other ones. If I execute this, the result will stay the same. Now, obviously, I was mixing up from which table came which, then I get these kind of errors. But there we go, stayed the same. Cool. Now we have here the full name and specified which columns come from which table. The next big question that might come up is how many revenue did we generate? In the sales orders, we saw there was no revenue because in this database we have also the order lines. So for each order, we might have multiple order lines on each order. And in these order lines, we see we have a quantity and a unit price. So if we multiply those together, we know the order line revenue. That means we need to go ahead and again extend our query. We want to also join to our order lines. Let's call them OL. Order lines on OL. And now I see, okay, an order line has an order line ID, but they are always also referencing an order ID. This is where we get now the bridge to our orders table. So let's join on this. And now we have finished our join. Now we can select from this table. We want the unit price and the quantity. So let's say we want OL.quantity and OL.unit price. I'll remove this again. And now we will have a look at the result. And there we see we have the order ID now multiple times here. Because let me also add the order line ID, because this order 73290 has 2 order lines. Now we have multiplied our rows here, and we want to see now per order line how much revenue did we generate. So I want to multiply those together. Then I can simply go ahead and say, okay, I can reference the orders here multiple times. Quantity times unit price. So this asterisk, the star, also indicates an multiplication. We could also add a plus here if it makes sense, but in this case we need to make multiplication, so we have the revenue. We've sold 50, each cost 32, which makes those together is our revenue. And if I run it like this, I get a new column where I have 50 times 32 is 1,600 in revenue. And now we see here no column name for now, because I did not specify a new name, because this is a calculation and in the database it does not have a name. And I can always go ahead behind here and say as order line revenue. I'll give it some kind of name that helps me identify what am I calculating here. And if I run this, there we have it. All right, the next thing we might want to organize is that we are not interested in all our data. We want to add a where clause to filter our data. And in this case, let's say we only want rows where the order date is equal to 2014-01-01. And if I run this, I only get records where the order date is the 1st of January 2014. If I scroll all the way down, you will see the order date always stays the same. This is how we filter in SQL, adding a where clause. Now, I am still not very happy with our result. I would like to see not the order line revenue, but the order revenue. So I want to add some kind of grouping here. I want not 3 rows per order ID in this case, or here's just 1, or here's 3. I want them to aggregate them by the order ID. And this is where the group by comes into play. And we will need to restructure our query then a little bit. The group by comes after the where, but before the order by. So here we will group by. And now I say, where do I want to group this result set by? And in this case, I want to group it by the order ID. So let's say .order ID. And if I try to run it, this will fail now, as I cannot have columns that are not in the group by condition or aggregated by. So let's say I am now not interested anymore in our custom ID. Oh, but well, we can still keep it because one order is always connected to one customer. So we just add another group by condition. The full name will also be always the same per row, so we will add the full name. We will add the order date. We want to group our results by the order date. In the end, it will just group it by the order ID because this one has the highest granularity in our dataset. The quantity and the unit price, they are coming from the order line, and we saw we have 3 order lines for the first order. So here we run into the problem that we cannot group by the quantity because then we have 3 rows again. But we can add aggregations here, and for example a sum. And when we do this, we can also give it then a name. Let's call it sum quantity. And we will do the same for the unit price. Sum unit price. Order line ID I want to get rid of because I don't want to aggregate by it, because then we are again at the number of 3 rows per order. Gone. And this one I will comment out for the moment. I want to ignore it. I will just add a comment. I can do it with 2 dashes here. And then I also need to comment out the comma. So we have 1 comma per entry here. Now, the last thing, I need to get rid of this comma. And let's run it. Now, as you see, we have only one row per order ID and all the other columns that are directly derived from this entry here. But what we see here now, we have a sum. The sum of the quantity, the sum of the unit price. This is the sum of the 3 rows that we have seen before. Now, what we can do is the same thing again. We do the sum of the quantity and multiply it by the sum of the unit price. And what we will see is we have here now 1,868. If I do another thing, which would be removing the second sum and multiplying them before, we see that we come to a different result. Why is it? We have the sum first, and then the whole result of the quantity times the whole result of the unit price. Or first we do the per row, per order line, the multiplication, then later the sum. Let's have a look what would be the right result. I will go ahead and open a second window here just to check it again. And I want to see only the results for the order ID with this number. Where order ID equals this order ID. And there we see we have 3 entries and we have 250 here, 75 here in revenue and 320 here. So in total it should be this value and not this one, because this one was first aggregating all of them, then all of them, and then the total multiplied, which is not correct. We need to multiply per row first, what we do here, and at the full end the sum. So this one is wrong. We don't want this one because this one does not make much sense. And then we call this as order revenue. No, we are not anymore on the order line revenue. Let's remove this and run this. And there we have it. Now, already a rather complicated query, but as you saw, we were growing it until the result that we wanted. What we have now is we have per order ID, customer and salesperson. We have the order ID in here, which is for the whole data set filtered to 2014, and we get the order revenue based on the individual order lines per revenue. So quite an extensive use case for all the keywords that you have in basic SQL queries.